All right, let's go ahead and continue on with precision. Here we are in part 6. Now that we've got part 5 successfully knocked off of our implementation plan overview, let's go ahead and mark it out. All right, so what are we going to be doing for part 6? Well, let's take a quick look. Let's go ahead and hide that layer, bring this layer up. Part 6 is all about player-enemy interaction, and what I'm talking about is we need to make sure that enemies and players can collide one another, and this can cause player death. So in order to get this in place, we need to first implement collision checking. We need to make sure that we're scanning for enemy and player collisions, and finally we need to make sure that player reset is in place and that it's doing such things as setting an invincibility time of just a second or so and setting that flicker up to let us know that we are invincible. But this was just that quick snapshot look at what needs to be done in part 6. Let's go ahead and dive in now and take a closer look at what we're going to do. So I'm going to come over here, hide this guy out, scroll all the way up, and add in a new layer. So here we are in part 6, player, enemy, interaction. So what is it that we need to do? Well, the good news is we don't need to do an awful lot. We don't need to do any complicated mathematics. We don't need to do anything that's going to require you to put on your logical thinking cap. Okay, maybe a little bit, but nothing really deep. We're going to start out by first going into the player class. And in the player class, the first thing we want to do is go ahead and get the reset method implemented. So reset. And reset is, of course, going to be taking in an invincibility time. Now, I am going to pseudo code once again, so just keep that in mind. So I'm just going to say INV for invincibility time. So how long will the player be invincible? But reset needs to do a few other things as well. It needs to center the player. It needs to go ahead and set invincibility time with what just came in. So set the invincibility time. And finally, start the flicker. And remember, we've got the flicker system in place several parts back. So that is the job of reset. From there, while still in the player class, we're going to move focus over to update. An update's going to be very simple. All we need to do is check to see if the player is invincible. And if it is, we need to decrement that invincibility time. Okay, simple enough. After we decrement it, we're going to turn right around and check it again, because if we're no longer invincible, we need to set the flicker to false. Basically, we need to turn flicker off. So this just boils down to if invincible, then decrement invincible, check again, and that is check invincibility. So do we have any invincibility time left? And if we don't, then what we need to do is, and I'll just go ahead and bring this one in, saying that we've checked again and we're no longer invincible. So what do? Turn flicker off. By simply setting it to false. That is all we need to get in place in update. So this gives us the ability to set an invincibility time by simply resetting our player and giving it a time. That centers up our player. It causes them to start flashing, and it now has an invincibility time that we need to chip away at. And then inside of update, which gets called 60 times a second, we're going to say, hey, is there an invincibility time? Yes, there sure is. Okay, well, let's decrement that time, so it's going to get lower and lower and lower until it finally hits 0. Now let's check again, because we just decremented it. If we have simply run out of invincibility time, let's turn flicker off because we're no longer invincible. Simple enough. So this is what's going to be done in player. Once we get that out of the way, it's now time to start thinking about interaction between the player and the enemy. So what we're going to do is we're going to go over to actor, and we're going to set up or implement a method over there. So let's go ahead and jot down actor. And inside of actor, we're going to be implementing check collision. And I did not mean to write a G. And if you recall, check collision is going to take in an actor A and an actor B. And we will simply compare against these two guys. So what does check collision need to do? Well, it needs to get the distance between the two actors. So get distance. Now, we've done this type stuff before. Except this time around, we're going to make it even easier. So get distance between the two actors. Then we're going to check to see if the distance is less than the two actors' distances added together. Which means, did we touch?
So that's going to have to take into account the radius.
You got it, of each actor, exactly. So, and then we're just going to simply return back if we've collided. So, good enough. And again, check collision, if you recall, is a static method so that we can simply call it by saying actor dot check collision and send it in actor A and actor B. So once we have this method set up and ready to work for us, we're then going to shift gears and go back to the game class, drop down to the update method, and in the update method we need to check to see if the player has collided with an enemy. Okay, so let's go ahead and jump down here. So we'll say update. Hang on. No, let's do to follow suit with how I've been writing this. So back in our game class, that looks better. Let's jump down a little bit. We're going to be taking a look at update. And in update, we're going to check to see if players collided. So check. I'm just going to say player enemy. Let's see if we've run into any enemies. And now, but, okay, follow me here. Only if the player is not invincible and the enemy is harmful. This is very important because even if we've collided, we don't want to kill ourselves if we are invincible at the moment or if the enemy is not harmful. So we're doing this check, but in part of coming up with the let's die, we need to make sure two things happen. So let me do this. In fact, I'll just jot it down this way. This will make a little bit more sense. I'll say if we collide. These two states need to be satisfied. Only if player is not invincible. Okay. Spell it half a dozen different ways. And if enemy is harmful. Okay, if we collide, ... die, only if the enemy is harmful, only if the player is not invincible, and if enemy is harmful. Okay? And how will we die? We'll simply set our game state to died. All right. This is our implementation plan. There is one new field that we'll be adding into the party, and that is just going to be a constant that is going to allow us to control our invincibility time. So it'll be a constant float. Invincibility time. And we're going to set it to 1 second. Okay? Now, let's see. Is there anything else in here I want to spend just a second and talk about? Yeah, I know. Let's go ahead and do this. And I can give myself just a little bit of room up here to do this. Let's take a look at this guy. So we'll come up here to look at him. So we know check collision is going to take in actor A and actor B. What are we going to do with them? So let's go ahead and jot this down. Now I'm just going to say A and B. But we know it's actor A and actor B. What we're going to do basically is get a float called distance that is going to hold, now I'm going to write down here just to give myself a little bit more room, a vector 2 dot distance between A's position, I'm just going to put POS, and B's position. Okay? Before, we've calculated the distance between two items ourselves, haven't we, Lemon?
Right, all the way back in Canon, we had to do some tests, and we had originally implemented Canon outside of XNA, so we didn't have access to the vector 2.
That's
or
right.
At the very least, we didn't go out of our way to gain access to it. But now that we're coding within XNA, we have all the XNA types available to us. Well, vector 2 has a distance method already built in, and it operates on two different vector 2s and returns a simple distance and a floating point.
Right.
So we don't have to implement that ourselves. It's already there for us.
Precisely. And so here we are taking advantage of it. So instead of creating a little utility method for calculating distance, we'll just use the vector 2's method that's available to us. So this information, the distance between A and B, the two actors, will be stored in distance, and then we could simply say return, and in a simple expression that's going to evaluate to true or false. So we can say if distance is less than actor A's radius plus actor B's radius. Okay? So if we had actor A and we had actor B, and this guy had a radius of 20, and this guy had a radius of 20, the two combined would be 40. If these guys were just touching, there's your 40 right there, correct? What we're checking for is the less than, okay? So if we end up with a distance of, let's say, 39, what would we have? We would have this 1 pixel overlap. Again, looking at our two distances. So we have to be touching. We have to be colliding because we're too close. So that's what we're looking for here. So this is simply going to return back true or false. True, we are colliding. False, we are not colliding. Anything you want to add to that, Logan?
Right, it's really just a simple distance check because of the fact that we're using circular graphics.
Mm-hmm.
Since looking at that diagram, you might be wondering what would happen if the corners were overlapping.
Ah.
The idea is that the corners are generally transparent because each of the graphical representations are circular. And since they're circular, that's why radius is so convenient, because they're perfect circles.
Exactly.
So the radius applies to any direction. So with that radius, once we go and drop below the two radii added together, then we will have visually overlapped, and that's the idea. When we have visually overlapped, we count that as a collision. And we can do that with a very simple distance check, since we can tell the radius of one versus the radius of the other. And if that's less than the distance, then we've collided. The nice thing is, since it's taking the two radii independently, that means we can do a collision check on two things that differ in size. We can take something like the smaller player and collide that to a larger cell or enemy, and everything will still work out because the radii are handled individually.
Exactly. All right, I think that's everything we need to have players and enemy interact with one another. Do you agree?
Yeah, it's a lot of different areas we have to hit, but it's generally a small amount of code in each area.
Yeah, it's not bad. It shouldn't take no more than about 10 minutes to get this whole thing knocked out. All right, well, with the implementation for Part 6 out of the way, let's go ahead and shift gears over to Visual Studio and begin coding it.